Hey everyone, welcome back to this paper 1 of Physics 9702 series. So to practice for the upcoming MCQ exam, which is going to be in June. Today, hey everyone, welcome back to the Physics past paper series. So today we're going to talk about the paper 1 variant 1-2 from the October-November 2024 series. Yesterday we talked about the paper 1-1 of the same session. Today we're going to talk about the 1-2. And just like yes, in the last video, this grade booster pack will be immensely helpful in dealing and tackling with the MCQs questions. Why? Because this contains not only the definitions and the formulae, but also minor points over here, such as the reasonable estimates that we will encounter in MCQs and a little bit in paper 2, along with the basic rundown and very basic summary of what we are encountering over here. So it does not include any of the details, but just major points that are very frequently asked in both paper 2 and paper 1. We have them over here. So this is going to help you immensely. And if you want to check that out, you can just go to our Patreon page, and this contains both for the AS and for the A2. Frequently examined questions for the theory, paper 2, paper 4, definitions and formulae, separate AS, A2, derivations and graphs also available to you. All right, so let's start the paper. All right. A physical quantity consists of a magnitude and a unit. Which row does not show a correct combination of a quantity and its unit? Quantity, mass, length, charge, temperature. Okay, mass, gram. The unit is correct, although it's not SI unit. Length, meter is correct. Charge, ampere. No, charge, the unit for charge is coulomb. So not show, so that is C. A small car travels in a town. What is a reasonable estimate of the kinetic energy of the car? So for the reasonable estimate, we know that the kinetic energy formula is mv squared. We need the mass. Reasonable estimate of a small car is 1000 to, let's say, 1300 kgs. And for the speed, let's go with 50 kilometers per hour, which is equal to 50 times by 1000 over 3600 meters per second. Since we need it in joules, we will be requiring meters per second. So half times by mass times by 50 times by 1000 divided by 3600 squared. All right, so we have this about 100,000, right? Around 100,000. So the order of magnitude over here is this one. All of them are greater than this. So the reasonable estimate would suggest that this is the order of magnitude over here. A solid bar has a cross section. Its length is measured as 50 plus minus 0.2 centimeter, and its width is measured as 2.00 plus minus 0.01 centimeter. These values are used to calculate the volume of the bar. Okay, what is the percentage uncertainty in its calculated volume? So we have a square cross section over here, which is given as 2 and 2, and the length is given to us as 50 centimeter. right? Okay. So we need the volume. So volume is equal to length, breadth, height, or length, width, uh, breadth, whatever you want to call it, or depth, height, whatever uh, third side we need. Or a better way would be, see, the cross-sectional area times by the length. So the cross-sectional area would be 2 centimeter times by 2 centimeter times by 50 centimeter. 4 times by 50, that is just 200 centimeter cubed. Now this is the volume. This is not the uncertainty. For the uncertainty, we will first find out the fractional uncertainty or the percentage uncertainty. Actually, we just need percentage uncertainty. Oh, sorry, I didn't even realize. So 0.2 over 50. And since both of these are the same, so 2 times by 0.01 over 2. So you get 0.2 divided by 50, divided by 50 plus 0.02 divided by 2 and then times by 100. This gets 1.4%. Good. Okay. Now moving on. The graph shows how the acceleration of an object moving in a straight line varies with time. The object starts from rest. Which graph shows the variation with time of the velocity of the object over the same time interval? Okay. So the acceleration, it is like starting from 0, ending at 0 back again. That means either the velocity is becoming 0 or it is becoming constant, right? So wherever the velocity is becoming constant, we will have to choose those. Okay, so this means that this goes because the rest of them velocity is becoming constant. In these, the velocity is becoming constant. In C, the velocity is just becoming uh, 0. Also, this is a sine graph. We know acceleration is the derivative of uh, velocity. So the derivative of sine graph would be a cos graph, which would go somewhat like this. Oh no, sorry, my bad. This would go somewhat like this. So we have to choose from A and B by looking at the other features over here. So acceleration over here has become maximum over here. That means we have a maximum gradient somewhere in between. Maximum gradient. So this would be correspond to the maximum gradient of VT graph. So that would be A over here because in between over here you have maximum gradient, not maximum peak. A stone falls vertically from rest. Air resistance is negligible. What is the speed of the stone when it has fallen through a distance of 0.4 meters? So this is easy. So we just have to use 2as v squared minus u squared. U squared is 0 since u is 0 since it has started from rest. So v squared would be 2 times by 9.81 since it is falling under the gravity. And it has fallen through a distance of 0.4 meters. So 2 times by 9.81 times by 0.4, oh sorry, squared. So that would be 3.139. So this is the squared value, 3.1392. So V would be square root of this value, that is 1.7. That is neither of these. Okay, so let's figure out where we actually went wrong. Stone falls vertically from rest. What is the speed of the stone when it has fallen through a distance of 0. Okay, that is correct. Square root 2 times by 9.81 times by 0.4. 2.8. Okay, I think then possibly we made a mistake over here. So V would be 2.8, which is B part. Okay, right. A ball is thrown horizontally off a tall building. So somewhat it's projected horizontally. The ground is horizontal, air resistance is negligible. Which statement about the motion of the ball is correct? Okay. Acceleration of the ball is always at right angles to the path of the ball. No. Acceleration is actually downwards. Ball follows a circular path until it hits the ground. No, it's not circular. Ball has a constant acceleration. That part is true. Yes. Ball's time in the air is proportional to the velocity at which the ball is thrown. It is related to it, but it's not necessarily proportional to it. So the only option that makes sense, it has constant velocity because acceleration because a is minus g downwards. A moving object strikes a stationary object. Collision is elastic. The objects move off together. Assume that the two objects form an isolated system. That means we can apply the conservation of momentum over here. Which road shows the possible values of the total momentum and total kinetic energy for the system before and after the collision? Okay, so they have said that this is inelastic. So that means the total kinetic energy before and after they are not equal. Momentum would be equal. So what we just have to look at over here, possible values, is total momentum before and after being equal, but kinetic energy before and after not being equal. So that is one clue over here. So this goes right away because collision momentum before after that is not zero. Sorry, not equal. So that means we have to look at which one of these is actually going to make sense. Now, total kinetic energy before and after collision are not equal. So that means D also goes away. So total kinetic energy before and after, they're not equal because this is inelastic. Furthermore, there is going to be a loss in kinetic energy. We can't increase the kinetic energy over here. This is always going to be the case. So they are becoming one object over here. Their masses are being combined. So their net velocity after the collision will be also corresponding the same thing, which means that there's going to be decrease in kinetic energy after, not increase, because we know that we can't create an object. Oh, sorry, we can't create energy. Energy is not input into the system. Energy is lost from the system. Although we are saying that this is an isolated system, but that's not what we are talking about. We're talking about an inelastic collision. So total energy after collision is not the same as after, and it's only going to be decreasing. So C will be making the most sense. All right. Question number 8. The graph shows how a quantity y varies with quantity x for an object falling vertically at its terminal velocity towards the surface of the earth. So the object falling vertically at its terminal velocity, that means v is constant. That means acceleration is 0. Okay. Which of these, which quantities could x and y represent? Now, we know that if it is falling could indicate decreasing displacement. And we know that the rate of change of displacement is velocity, which is constant over here. So that would have a constant gradient. So this could be distance over, x would be the time, and b could be the height above the surface. A ball of mass 2 kgs travels horizontally with a speed of 4 meters per second. A ball collides with the wall and rebounds in the opposite direction with a speed of 2.8. The time of the collision is 150 milliseconds. What is the average force exerted on the ball? Okay, so we know that the force is rate of change of momentum. So the change in momentum over here is that this is u direction 4 and this is v direction 2.8. So v minus u is in other direction. So technically we are adding the same things. So v minus u, you could say, because if we take this direction as positive, then u is in negative direction. So minus u. Divided by a change in time, that is 150 milliseconds. So 150 10 raised to power minus 3. So 2 times by 6.8 divided by 150 times by 10 raised to power minus 3. 90.66, so roughly about 91. Two train carriages, each of mass 5,000 kg, roll toward one another on a horizontal frictionless track. One is traveling at a speed of 2 meters per second, the other at a speed of 1 meter per second. They collide and join together. What is the kinetic energy during the collision? What is the kinetic energy lost during the collision? So how we can do this is to figure out what's the velocity after the collision. So we apply the principle of conservation of momentum. So total momentum before collision, that is 5,002 minus, because this is going in opposite direction, so 5,001. And now momentum after, they're both joining together, so that is becoming 10,000 times by v. This is what we have to figure out. So 5,000 times by 2 minus 5,000 is just 5,000 divided by 10,000, so that is just half. Or 0.5, right? So EK before, or EK lost basically, so half M, sorry. Yeah, actually, sorry, would be 5,000. The total kinetic energy is 2 squared, 1 squared before, and after would be half times by combined mass 10,000 and times by 0.5 squared. That's what we have to do. So 0.5 times by 5,000, 2 squared plus 1, that is just 5, because 4 plus 1, 5, minus 0.5 times by 10,000 times by 0.5 squared. So 11,250, that is C. All right, moving on. Which single condition must apply for an object to be in equilibrium? The object has a constant non-zero acceleration. No, because acceleration has to be 0. Object is stationary. No. There are no forces acting on the system. No. The resultant force acting on the object is 0. That is the adequate condition over here. A kite is in equilibrium at the end of a string. The kite has 3 forces acting on it: the weight, the tension T in the string, which is going to be going this way, and the force F from the wind. Okay, force F from the wind is going to come this way because it's lifting it. Which vector diagram represents the forces acting on the bike? So first off, the keyword over here is equilibrium. So that means it's going to be a closed triangle over here. So weight is downwards, tension is going towards the left. So that means this is gone and this is gone. So from the ones left, force is going towards the right because we know that this is uh, yeah, sorry. The force is uh, going towards the right, the lift force, the wind basically. Now, the sum of force over here has to be a closed triangle. If we look at C, this is not a closed triangle over here. So this is not correct. A is correct because if you notice, this is a cyclical closed vector diagram over here. So the triangle of forces is a closed triangle. So A part. Four forces act about a point P, as shown. The forces act in the same plane and produce no resultant moment about P. What is the length x, y? Okay, so what we need simply over here is the net moment over here. So we need an expression for the net moment. So if this is 60 over here, this angle is 60 also over here. So we need the perpendicular distance. So this would be we don't know what the length is. So let's try making it into the sum of moments equation, anti-clockwise moments, clockwise moments. So clockwise moments would be this one, and anti-clockwise moments would be these two. Right, okay. So counterclockwise moments about P basically, they would be 5 and 5, right? So we don't know what this length is. Let's call it xp over here and yp. So we have 5 times by xp sine of 60 plus 5 times by py or yp sine of 60 also. Now clockwise moments about P are going to be similar. So 6 times by 7 plus 6 times by 3. So this is going to be 42 plus 12. Sorry, 42 plus 18. 6 times by 7. Yeah, 18. So that is 60. So that means this is also going to be equal to 60. Now remember, we don't actually need to find out xp or yp. We just need to find out the length. So we know that 5 times by xp sine of 60, remember that is under root 3 over uh, degrees. Yeah, under root 3 over 2 basically. So under root 3 over 2 plus 5 times by yp under root 3 over 2 is equal to 60. So we take away the 2 that on the other side because this is going to be what's left out. So 60 times by 2 divided by 5 under root 3. So 60 times by 2 divided by 5 divided by root 3. So 13.8. So that xy, which is going to be equal to this, is going to be 13.856, roughly about equal to 40. So 13C. A rectangular block of lead of density 1.13, 10 raised to power 4, and sides of length, has sides of length 12 centimeter, 15 centimeter, 10 centimeter. What is the maximum pressure the block can exert when resting on the table? So we have to figure out which cross-sectional area will cause a maximum pressure. So we have choices. First off, we need to find out the mass now. Maximum force over area, basically. So we need to figure out the weight is equal to mg. So mass is equal to density times by volume. So density is 1.13, 10 raised to power 4. And these three are in centimeters, so we need to convert them into meters. So 0.12, 0.15, and 0.1 times by 9.81. So 1.13, 10 raised to power 4 times by 0.12, 0.15, 0.1, 9.81. So this is roughly about 199.5354, roughly about 200 newtons. So this is the weight. So pressure is equal to the weight over area, because this is going to be the force over here. So roughly about 200 divided by, or like the 199 over here, 199.5354. Now the cross-sectional area, we have to decide which one of them would be the most. So we have, let's test out with the 200 or 199, doesn't matter. We can try out with 0.12, 0.15. We can try out with 0.12 and 0.1. And we can try out with 0.15 and 1. So how do we know which one to select? We can look at it algebraically. The numerators are almost all the same. So highest pressure would come from the lowest denominator. So lowest denominator, we just have to figure out which one of them is the lowest. So 0.12 times by 0.15 is obviously going to be the highest. Sorry, no, wait, hold on. I'm not claiming anything. 0.018. So this is 0.018. 0.12 times by 0.1, that is 0.012. 0.12. And 0.15 times by 0.1, that is 0.015. So lowest is this one. So 200 divided by answer is this value, and this is in Pascal, so we divide this by further 1000 to make it into sorry, my bad, this was supposed to be 0.012. 16.36. Okay, yes, this is correct, because we selected 0.01. All right. A model car travels at a constant velocity of 12 meters per second in a straight horizontal line. The input power to the engine of the car is 800 watt. So it is traveling at a constant velocity of 12 meters per second. Input power to the engine of the car is this. The efficiency of the engine is 60%. What is the total horizontal resistive force on the car? So they have said that input power to the engine is 800 watt and the efficiency of the engine is 60%. So that means power output of the engine is 800 times by 60%. So 800 times by 0.6, that is 480 watts. Now, if we consider the forces, so let's say this is the driving force, this is the, let's say, frictional force. Let's call it D, for example. So resistive force, let's call it R. So D minus R is equal to net force, which in this case, we know that this is zero over here because it's traveling at a constant velocity. However, if we multiply V on all sides over here, so we get delta F times by V, which is the net force times by velocity, net power output, basically. The power output due to the engine minus the power loss due to resistive forces. That is also equal to zero because we already know that the driving force is equal to the resistive force. So that means that the power output by the engine after considering efficiency is equal to the power lost due to the resistive forces also. So that means we only need to consider this. So RV is also equal to 480. So R will be equal to 480 divided by 12 meter per second divided by 12. So that is 40. That is B part. Oh, I think I forgot this question number 15. What is the definition of power? So this is straight away work done per unit time. We don't even have to, worry about looking at this. So work done per unit time. Work done per second, although you may seem like that is correct, but second is the unit, not the quantity itself. Work done in unit time, that's different phrasing over here. So that's it. Let's move on to the next question. All right. Which statement represents the principle of conservation of energy? That states energy cannot be created or destroyed but can be transformed. Or it could also be said that the total energy of an isolated system remains this constant. Total energy in a closed system is constant. So yes, closed system means that there is no energy loss from that system or input to the system. So in a closed system where there's no energy input output from the surroundings, so the total energy would remain the same. A barrel of mass 50 kg is loaded onto the back of the lorry 1.6 meters high by pushing it up a frictionless plank 3.4 meters long. What is the minimum work done? So minimum work done that is required is getting this barrel from over here to over here. So that means we have to um, at least work against the uh, gravitational field, or we have to do work against the gravitational field, gravitational force, or the weight. Work done against weight, work done against gravitational gravity, whatever you want to call it. So how do we calculate this? So mgh, basically, that is the minimum work done. We are not talking about the velocity of pushing it up, so otherwise that could also be the work done included. So 50 kgs times by 9.81 times by 1.6. So that would be 50 times by 9.81 times by 1.6. That is 784. So to two significant figures, this would be the correct answer. What is the unit for stress? So unit for stress is basically force over area. Force is kg meter per second squared and area is meter squared. So this becomes kg Meter 1 minus 2 is minus 1, second minus 2. So A part or option A. The graph shows the relationship between stress and strain for three wires of the same linear dimensions but made from different materials. Which statement is correct? Okay, so we know that the gradient of this graph tells us the Young modulus, E. Which statement is correct? The extension of P is approximately twice that of Q for the same stress. No, no, because if you look at this over here, it's the other way around. So the strain, sorry, no, for the same stress, it's the other way around. For Q, it is roughly higher. However, it's not the extension; it is the strain. But since they are of same linear dimensions, we can say extension. So that is not correct. The ratio of Young modulus for P to that of Q is approximately 2. So approximately 2, that could be said because the gradient is approximately twice as that of Q. So yes, that could be true. For strain less than 0.1, R obeys Hooke's law. For strain less than 0.1, so 0.1 is this part over here. So yes, for all three, the Young the graphs are linear. That would be that the Young modulus is constant over here. So the gradient is constant. Young modulus, we only need, for the Young modulus, we only worry about the linear part. So I think that would be correct also. The Hooke's law also correct, because they are, again, they are of same linear dimension, so stress strain relationship would be the same. So that means both 2 and 3 are correct. 1, 2, 3, no. 1 and 3, 2 and 3 only, yes. Four solid steel rods equally support an object weighing 10 kilonewton. Each rod is of length 2 meters and cross-sectional area 250 millimeters squared. So basically you have four rods. This is, let's say this is the ground and this is the weight of 10 kilonewtons. This is the weight, 10 kilonewtons. And since it is being supported by four rods equally, so the thrust would be this way, equally divided. So since it is written equally, so that means since this is in equilibrium, all of these have T, 10 kilonewton. Since this is in equilibrium, 4 times by T, so T would be basically not 250, 2500. Okay. So now this is the force or the load exerted on one rod over here. So we know that Young modulus is stress over strain, so we can find them individually. So stress is force over area. Force is 2500 newtons divided by cross-sectional area, which when we convert this into meter squared, that would be 10 raised to power minus 6. And strain 0.10 millimeters, and 2 meters converted into millimeters, that would be 2000. So 2500 divided by 250 times by 10 raised to power 6, this is 10 million, 10 raised to power 7 basically. And this one, on the other hand, we have 0.10 divided by 2000. So if we convert this into scientific standard form, that is 10 raised to power minus 5. So once we plug it into this formula, stress over strain, So 1 10 raised to power 7 divided by 5 10 raised to power 5. So we get 1 divided by 5 10 raised to power 7 minus 5. We get, oh no, sorry, this is plus 5. Plus 5. This is 10 raised to power minus 5. So plus 5. 2 10 raised to power 11. So B part. All right, moving on. The graph shows how the length of a spring varies with the force applied to it. Two areas P and Q are labeled. Which area represents the work done in stretching the spring? So we know that the work done is F dx, basically somewhat like this. However, over here, the force is not constant over here. Anyways, so the work done that we are considering over here has to come from the area that in where the length is changing. So in this part, length is not changing. Length is only changing in P part. So we need to use the relationship between force and change in length only in that part where the length is changing, where the deformation is happening, where the stretching is happening. So it's only area P. All right, let's move on. A horizontal beam of vertically polarized light of amplitude A is incident normally on polarizing filter. The transmission axis of a filter is at an angle 50 degrees to the horizontal. What is the amplitude of the light in the beam after it has passed through the filter? Okay, we know that the intensity is directly proportional to the square of the amplitude. Maleth's law suggests that the polarized waves intensity is related by I is equal to I naught cos squared theta, where theta is the angle difference between the transmission axes of the filters. Now, what we have also over here that this is proportional to intensities are proportional to amplitude squared, which loosely means that we can rewrite this in terms of amplitude like this, cos theta. So, which means that since we have A over here, and let's call it A prime as the new amplitude, so we can just do cos of 50 degrees, and that would be time. So the normal mode, that would be 6.4, so that would be 0.642 A, and this is the correct answer. All right, moving on to question number 24. A progressive longitudinal sound wave moves through the air. The diagram shows the position of the air particles along part of the wave at one instant. The point Q is at a distance of x, from point B. Which graph shows the variation of displacement of air particles with distance from P along the wave? Okay, so if we notice over here that this is a point of compression, this is a point of rarefaction, compression, and rarefaction. So this means that this x distance over here is between two points that are in phase. So this point is in phase with this point, and the compression points, they are in phase with each other. So 2 points in phase, the distance between them is simply the wavelength. So A and B, as you can see, that x represents half the wavelength, so they are eliminated right away. All right, now to decide between C and D, we have to look at the displacements of the particles themselves. So to understand that, we know that at the compression sites, there's a higher pressure, so particles are pushed closer to each other. Similarly, over here, the particles are moving in this direction. Particle moving this way, particle moving this way, particle moving this way. However, what does it say about the particles at these points. So if this particle is going towards the right, this particle is going to the left, logic dictates that this is at zero displacement. Similarly, these two particles going in opposite directions, right in the middle would be zero displacement. Zero displacement, zero displacement. So between 2 points that are in phase, for example, from this point to this point, there is another zero displacement over here. So that just is C. That's it. Nothing more over here. Moving on. An electromagnetic wave in free space has a frequency of 310 raised to the power 16 Hertz. Which rho gives the principal region of this wave and an example of the electromagnetic wave with a lower frequency? All right. So if we notice over here 310 raised to the power 16, 310 raised to the power 16, this is the end of ultraviolet and start of X-rays over here. So this means that a wave of a lower frequency so could be a visible light. Since if you notice a wave with a lower frequency X-rays, X-rays have a higher frequency than ultraviolet. D cannot be correct. Infrared, visible light, they cannot be correct because visible light have higher frequency than infrared. Not to mention infrared doesn't have that frequency range. Similarly, X-rays have a higher frequency. So these can be cancelled out without even looking. So like without even, reading it. So 310 raised to the power 16 is not for the infrared. It could be for ultraviolet. So C is the correct one. All right, so moving on. All right. A source of sound emits waves of constant frequency. The source moves at a constant speed in a straight line relative to the stationary observer. Which velocity of the source gives the smallest observed frequency? All right. So we know the Doppler effect over here. So for example, if this is the observer and this is the source over here, if it is moving towards the observer, it's going to increase the observed wavelength over here for the observer, which is the Doppler effect. But if it moves away, the Doppler effect causes the wavelength to be increased, thereby decreasing their frequency. We need the smallest observed frequency, so we need the away from the observer. And more the speed, more reduced frequency. So that's it. Why? We can see the formula also. So formula for that is V over V plus S. Yes, this one, the receding source. So where Vs is the speed of the source. So higher the speed, lower the denominator over here, which means higher the speed of the source, higher the denominator, lower the entire value of the fraction, which means lower the observed frequency. So that's it. So that's the B part over here. What could describe the time base of the cathode ray oscilloscope? So basically, time base is the time per one division. So that is the D part over here. What happens when two waves superpose at a point? Their amplitudes are added together, their displacements are added together, their frequencies are added together. Okay, so only the displacements are added together. Amplitude is the maximum displacement, so but the general form is that it's the displacement. An electromagnetic wave is diffracted as it passes through a single slit. The width of the slit is larger than the wavelength of the wave. What change will decrease the amount of diffraction of the wave? Wait, sorry. The width of the slit is larger than the wavelength of the wave. So the question is saying that we need to decrease the amount of wavelength, diffraction of the wave. If we increase the wavelength of the wave, diffraction increases. If we decrease the frequency of the wave, Again, that increases the diffraction. If we decrease the time period, that means increase the frequency. That decreases the amount of the diffraction of the wave. Because lower time period means uh, higher frequency. Higher frequency means more waves are able to pass through. So that means the diffraction would be reduced. So B part. Okay, the diagram shows a visible light incident normally on a diffraction grating. The pattern of intensity maxima forms on a screen. A line connecting the center of the fourth order intensity maximum with the center of diffraction grating forms an angle of 53 degrees with the center line. The grating has a spacing of line spacing of this. What is the wavelength of the incident line? So that is just simply n lambda d sine theta. So lambda is equal to d, which is 2.7, 10 raised to power minus 6. Sine theta is sine of 53 degrees divided by fourth order. So that's all what we need. So 2.7 times by 10 raised to power minus 6 times by sine of 53 and divided by 4. So we get this. Let's convert it into the standard form. So we get 5.390, 10 raised to power minus 7. So this is the only one, B part. A horizontal glass tube closed on one end has a layer of dust laid inside it on its lower side. Sound is emitted from a loudspeaker that is placed inside. Sound is emitted from a loudspeaker that is placed near the open end of the tube. Okay, like this. Frequency of the sound is varied, and at one frequency, a stationary wave is formed inside the tube so that the dust forms small heaps. Okay. The distance between four heaps of dust is 30 centimeters. Speed of the sound in the air in the tube is this. What is the frequency of sound emitted by a loudspeaker? Okay, now this is easy to work with because these points represent nodes and these points over here represent antinodes. So these are antinodes, 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 and this is a node, this is a node, this is a node, this is a node. So a node to node distance is half the wavelength. So half wavelength, half wavelength, half wavelength. So that is 1.5 of half, 1.5 times by half wavelength. So that's what we have over here. Or 3 times by half wavelength, sorry, my bad. 3 times by half wavelength. That's all, 3 lambda by 2. So that's what we have over here. We need the, since we have the distance 30 centimeter, we can find out the lambda. 30 times by 2 divided by 3, that is going to be just 20. So this is 20 centimeter, which is 0.2 meters. Now we need the frequency, that would be V over lambda. V is 330 divided by 0.2. That is 1.65, 10 raised to power 3, or 1650. All right, moving further. There is a current in the resistor for a short time interval. Which statement about the total charge that passes through the resistor is correct? It can take any value. It's an integer multiple of elementary charge. This is correct. So any charge over here, it has to be an integer multiple of the elementary charge. It is the elementary charge? No, not necessarily. It is the rate of flow of current? No, that is the current. It can take any value? No, that is not correct. So 32B is correct. Now, the potential difference V across a filament lamp is slowly raised from 0 to its normal operating value. Which graph represents the variation V of the current I in the lamp? So it's easy to identify this. This is going to be A. So as the potential difference increases, current decreases because resistance starts to increase because of higher temperature. An electric current of 12 ampere is in a wire of length 0.35 meters. The average drift speed of the free electrons charge carriers in a wire is this. How many free electrons are in the wire? Okay, so we have this NaeV. N is the number density, basically number of charges or number of charges per unit volume. That's what we have over here, or that's what we need over here. So we have current 12 ampere. If we can find out the number density, we can find out the free charges, number of free charges. So N is equal to I over AeV. So 12 amps divided by cross-sectional area, which is, so cross-sectional area directly isn't given, but we're given the length over here. So we know that V is equal to A times by L. So A would be, the length is given over here. So A would be V over L. Right. Oh, we can substitute this over here. Never mind. So we have N over V, which is AL over here, or AL, yeah, equals to, again, I over A EV. So the A and A get cancelled out. So this means that N can be found by I times by L over EV. So I is 12 amps, length is 0.35, divided by E is 1.6, 10 raised to power minus 19, fundamental charge, and drift speed is given as 5, 10 raised to power minus 4. So let's calculate. You have 12 times by 0.35 divided by 1.6 divided by 5 times by 10 raised to power. Now we deal with the powers of 10, 19 plus 4. We get 5.25, 10 raised to power 22. So this is the B part. And that's it. All right, moving on to the next question. Three resistors are connected to a cell of negligible internal resistance. Which circuit has a combined resistance of 100 ohms? Okay, so remember that whenever you have parallel uh, of this becomes 50. So parallel combination of 100 and 100, they become 50 ohms. So I think B would be the correct thing. 50 plus 50 is 100, but just to go through the rest of them all, let's see this also. So 1 over 100 plus 1 over 50. So 1 divided by 100 plus 1 divided by 50 plus 100, that 133 roughly. That is not 100. This 1 divided by 100 plus 1 divided by 100 plus 1 divided by 50. As you can see, this is 25. Again, not true. This is just 250, 250. So that is not. So B, by just simple observation or simple inspection, we can do that. Each of the Kirchhoff's laws is statement based on conservation of physical quantity. Okay, let's see. So this is easy because these are, as you can see, first law based on conservation of charge and second law based on conservation of energy. So straight away, this conservation of charge and energy. That's it. A cell with electromotive force 1.5 volts delivers a current of 0.26 amp to a resistor of a resistance 5 ohms connected between its terminals. What is the internal resistance of the cell? Okay, so what we have over here is an EMF with internal resistance, and this is connected to a resistor of resistance 5 ohms, like this. This is 1.5 volts, and this is small r, internal resistance. Current flowing in the circuit is 0.26 amp. So the net resistance over here is 5 plus R, simply. So I is equal to V over R effective basically. So V is 1.5 divided by 5 plus R, and that is equal to 0.26. So R can be found from 1.5 divided by 0.26 minus 5. So 1.5 divided by 0.26 minus 5, and that is 0.769, and that is going to be the D part. What is not a quark flavor? So quark flavors are also listed. Let's see, sorry. Yeah, okay. So quark flavors are up, charm top, down, strange bottom. Let's see. Charm, Maison, charm, strange, and up are there. Maison is a hadron, is a type of hadron, which is a combination of quarks. So B part. How many down quarks are in a nucleus of hydrogen 3? Now, to do that, we need to know the number of protons. Number of protons is equal to 1, and neutrons is equal to 2, because nucleons is equal to 3. Now, in protons, we know in protons we have up, 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 down, and in a neutron we have up, down, down. So in 1 times by 1, and we have 2 times by 2 down. So we have 1 and 4, so we have 5 down quarks included. An isotope of boron decays to beryllium by beta plus emission. Which particle is emitted in addition to the beta plus particle? So you can see this over here, that it's going to be neutrino, simple electron neutrino. That is the particle that is emitted with the beta plus particle. So neutrino, simple neutrino. And that's about it for this paper. Hope you learned something. If you have any problems, reach out to us to the comments. This grade booster pack is listed in the Patreon page under the complete AS and A2 grade booster pack. So you can buy this through the Patreon page and start reading through this, because this is going to help you get your A grade in the MCQs exam. All right, so see you in the next discussion. Bye-bye.